Your speaker and microphone are muted. I don't think they are. I think they're working perfectly. I can check that if needed. Right, yeah. So yeah, chapter 7 was the suggestion. Just going to quickly unmute that. Hello, hello? Hello? Yes, it's working. Perfect. Right. Just checking the microphone. Right, let's go. So yeah, chapter 7 was the suggestion. Just a reminder of what topics we're looking at. Topics that we're looking at. If you go to the revision channel, you can either have a look at the picture that I posted or actually go into the comments there rather than actually download it. If you do download the actual PDF, you might want to print it off. Having a printed version of your revision checklist might be beneficial, so you can do things like this. Right, okay, so do you know what, I'm happy with that. I don't need to revise that for a while. Do you know what, I'm happy with that, I don't need to revise that for a while. Yeah, so if you have a printed version, that's my recommendation, have a printed version for your purposes of your revision. You can start seeing, okay, where's my gaps in my knowledge, where am I less confident, where do I need to practice more of? Or an alternative approach, which some students like to do, they like to tick them off as they come through, and then go again. Alright, now that is a good strategy because you're doing things at least twice. That's how you take things from short term to long term. Okay? And what you can see is you can see which topics you practice more than others. And you can see, okay, maybe I need to go back here and then again. Alright? So yeah, that PDF is available in the revision channel of this here. Yeah, let's have a look at correlation and then do some correlation tests. If you get a chance to do some regression, fantastic. If not, no worries, we'll do it in class in the coming lessons. And of course, as we go on. So yeah, this is the question I found. He said. Legacy question 2007. And without even using a calculator, because we don't have the data, we've got to guess at the PMCC value. Alright, you see how as x increases, y increases, so it's positive. Actually, first thing. We're aware that it's on a scale of 0 to 1. 0 meaning no correlation, 1 being perfectly linear. Right? Doesn't necessarily mean steeper or shallow. It's more of a case of, do those points fit a line or not? Okay, how dispersed are they? Now, line of best fit, we've got a better technique. We refer to it as the lines of regression, the least squares regression line. But you can see some residuals. So it's not quite 1. It's definitely not big. No, it's definitely not 1. It's not quite 0.9, but it's strong-ish. Moderate. Yeah, moderate. So somewhere around the 0.6 mark. I'll show the mark scheme just to give you an idea of what you might get scored on. This one here. What do you reckon for that one?
Not 0, but close.
Yeah, close to 0, isn't it? Yeah. If you put 0, you will get the marks. Right? It's clearly, if there is some, it's super weak. Yeah. I mean, you can't quite tell that. Minus 0.02 maybe. I don't know. But it may be more negative than positive. But it's clearly there is no relationship between this data. So PMCC is not appropriate. Okay. Let's have a go at another one, and I'll let you have a go at the next. Is this the one I'm thinking of? It is. This one baffles students every time. What would you think?
this the one with?
This is the one where.
Two positives or one negative?
That's exactly it. This is the one. This is the one. If they were analysed separately, they would be very strong positives. But because your X bar and Y bar splits it into quadrants like this, you're connecting top left with bottom right. I know it's weak, but it's actually negative. That's what it would do. It would take X bar and Y bar, and it would sit and it would find the smallest differences. And the smallest differences for the line of regression are actually for a negative line. That's not too bad. Whereas if you plot the line in between, there would be big gaps. Okay? But yes, negative, I don't know. Weak. Yeah, you had to say negative. Clearly it's not strong negative, but it's negative. I reckon that part C is worth 2 marks. 1 mark for the minus, and then 1 mark for the strength. Fascinating. Alright, a nice little follow-on question would be, explain how you would investigate further. And like Henry said, you're right. You would have to maybe do separate analysis. Look at those points. That would be positive 0.95. It's almost 1, it's almost a straight line. The same for this one as well. Right? Because it's split up by X bar and Y bar actually creates a negative, you actually get a negative instead. Can you see why that's not appropriate to do a PMCC value or test in its current form? The scatter diagram is the starting point of any PMCC. If you forget it, you might miss something. Okay? Outliers, multiple data sets, non-linear data, or the fact of why are you doing PMCC? Clearly it's 0. I don't need a calculator to tell me that's 0. Yeah? Okay, so let's have a quick look scheme for left. I have a little question, a quick one. What did I say? Did I say 0.6? The actual value is 0.8. However, 0.6 is between 0.5 and 0.95. If you said something weaker, yeah, so as long as you said it was positive, as long as you put 0 point, yeah, and it was positive, somewhere between 0 and 1, it'll give you 1 out of 2. B was actually 0. Yeah? So if you guessed at a negative, if you guessed at a positive, as long as you said it was very, very weak, so minus 0.1, positive 0.1, you don't mark that one. And then part C, like I said, if you guessed at a negative, if you identify by X bar, it's negative, okay, you've got 1 mark. It was actually quite strong. Do you know what? Me saying minus 0.4, I only got 1 mark out of 2 then. Do you see that? I don't think it was that strong. I honestly didn't think it was that strong. What was I saying? Minus 0.4. Can you see how my 0.4 doesn't fit in the 2 mark out of 2 category? Right? So me being honest, I would have got 2 out of 2 on that. I can't see how that is a strong negative. I admit it's a negative, but I can't quite see how it's a strong negative. The value is actually minus 0.7. Okay? But at least we have a strategy for that situation. We haven't seen it since, and obviously that's the legacy question. So what we've got here is we've got an actual data set. Well, first of all, part A, task for you to have a go at, have a guess at part 1 and part 2. What do you think? Just give you a minute and a half, I think of those. The reference you'll want to make a note on your paper is Jan 11. So without making any calculations, A part 1 and A part 2. So Jan 11.
strong person.
Strongish, isn't it? Strongish. So positive 0, 'cause it's not 1, is it? 1 is a perfect straight line. Positive 0.7.
Or 0.8. So
8, yeah, I think you
0.7.
get it great. I think you get it great. 7, I think it's fine. 6 might just squeak it, yeah? We'll have a look at the maths in a minute. Part 2, I'm hoping you spotted it.
Negative.
It is negative, but it's definitely weaker than the first one, isn't it? So minus 0.3, 4, 2, I don't know.
Minus 0.7.
Yeah, minus 0.2. Right, so let's have a little bit more room that the little goal post that we're looking for. They would have accepted anything at least 0.6. Whew, so me saying 0.6, I just want to get that one. Thank goodness. It's quite generous that they'd have accepted 0.98. That is not 0.98, that is nowhere near 1. Yeah, hence why I was erring on the side of 0.6 instead of 0.9. The actual value is 0.8, probably. Yes, negative, if you said super weak negative, yeah, like minus 0.1, you'd have got it, minus 0.2, would have got it, minus 0.3, would have got it, minus 0.4, would have got it, even minus 0.5 would have got it. The actual value was minus 0.3. Yeah, yeah, on the dot, there it is. Oh, okay, now, so that's just a bit of an overview of it, kind of an introduction of just guessing R and understanding R and seeing it and why scattered diagrams are useful. Now, the actual calculator use, if you put into your calculator list 1 and list 2, the per data, so you put your X into list 1 and your Y's into list 2, you're able to do a regression calculation. So the sequences of buttons, when you're in your list 1 and list 2, you type your data in, if you press the calc button, which I think is F2, you're doing some regressional analysis, you're doing some linear analysis, and that's why you press X. Of the two options, you can press either for now, but when we get to regression, you'll be doing A plus BX, so it's kind of routine to do A plus BX, right? So have a go at those button sequences, that sequence of buttons, type in the data into list 1 and list 2, and create your R value. And because it's coming from the calculator, it wouldn't be worth 3 marks anymore, it'd be worth 1. Let's see what we get. These X values are very similar, aren't they? There's not much variation in these X values. Oops. because I'm super sad, I remember the answer, so I know I've got it right. But here's what I did. Well, not necessarily earlier, but just now. Right, so I've tacked all the X into list 1 and the Y into list 2. And that sequence of buttons is calc, regression, X, because we're doing a linear analysis. And we can press either, but A plus BX is probably more beneficial because we'll do that for regression anyway. And it's the R value that we want. R equals 0.757. Do we agree? Tedious to type in, but it's a data value coming from the calculator, hence why it's worth 1 mark rather than 3. The reason why it used to be 3 is because it used to be a formula, not everyone had calculators, etc., etc. But yeah, 757. Now, we've already used terminology like weak and strong and positive and negative. We just need to use that formally now for a conclusion. Well, not necessarily a conclusion, but an interpretation. Assuming that they can be considered as a random sample. If it's not a random sample, then the sample we take is biased and doesn't tell us anything about the population anyway. This is a strong positive. Correlation. And also we think it's not 0.8, it's 0.9. I can't put strong-ish. If I could put strong-ish, I'd put strong-ish. As soon as you get to 0.9, then you'd be probably saying very strong. Right? As soon as you get to 1, you are saying perfect linear. Anything less than 0.4 is weak. 0.4, 0.6, that's your middle range. 0.4, 0.6 is the moderate section. As soon as you get to 0.7, it's strong. Okay? So that's our first mark out of 2, strong and positive. It's very easy to forget the word positive, yeah? It's easy to remember negative if it's a negative value, because it says minus in your calculator. Oh, right, I need to remember it's a negative. But it doesn't put a plus to remind you that it's positive, does it? Alright, so that's quite, believe it or not, the easiest questions are sometimes ones that you don't say. So, strong positive correlation between what and what in context. So, between X and Y, what was X? X was centimetres. No, circumference. Circumference. I didn't realise you learned it this week. Arise circumference? No? That's it? No? Okay, wait in this job. Wait it. Between circumference, which is X, and weight. Of new criticals. Okay, good. I'll just quickly show you the mark scheme just to make sure we're happy with how the marks are allocated to that question. So 0.757 would be worth 1 mark. None of this 3 business, none of this formula business, just no calculator does it all for us. Strong. So we couldn't say strong-ish, but fairly strong would have been acceptable. Moderate positive. Oh, they would have accepted moderate. Interesting. Strong, isn't it? Positive, we have to have the word positive. Alright, so you have to say positive and you have to qualify the strength to get that first mark. Correlation between circumference and weight of balls. Okay. Yeah. I'm not going to say my usual inappropriate joke because I'm recording this for the purposes of YouTube. I kind of want to do that one. But first, Dr. Hannah has a clinic for older patients. She asked a medical student So select a randomly selected sample of 25 male patients between 55 and 65. Clinical records, heights, weights, waist measurements. Lenny, the medical student, was asked to calculate the 3 PMCC values. Now, this is what Lenny got. Lenny got 0.365 between height and waist, 1.16 between height and weight, minus 0.583 between weight and waist measurement. For each of these values, we need to say whether it's definitely correct, probably incorrect, definitely correct. Now, we know there's only 3 values there, and you're being asked to categorise by 4 different things. One of them will be used. Okay? The one that doesn't get used is definitely correct. You can never ever say something is definitely correct. Welcome to stats. Stats 101. You can never say your data says that something is definitely correct. You can say that there's evidence to suggest. Yeah? It's probably right, or it's probably wrong. Okay, that's all you can say. Yeah? One of those 3 values is definitely wrong. Do you see it? Should be screaming at you in the face. One of those things just doesn't belong there. Do you see it? It's impossible, isn't it? Alright, so part B definitely incorrect. And the reason why it's definitely incorrect is because you can't have an R value bigger than 1. 1.16 is bigger than 1. R is measured, yes, on a scale of 0 to 1, yeah, but from minus 1 to plus 1, and of course in between you can include zeros, right? So you can't have a 1.16, that just makes no sense. Now, of these 2 things, you're going to have to make judgments about what you'd expect, alright? There's a little bit of limited common sense that's required, alright? Height, so the taller you are, would you expect a lot, a wider waist? Would you expect a positive there or a negative? I mean, it's easy to answer this one. What about this one? Weight and waist. I think that's the easiest one to answer there. What would you expect, alright? Now, I'll be honest with you. As my weight decreased, so did my waist measurements. I've gone from a 38 waist to a 34. Thanks for asking. Yeah? But I've also lost 3 stone. Can you see that? Yeah? So we would have expected a positive. So this one's probably wrong. Probably incorrect. You'd expect a positive, wouldn't you? You can't say it's definitely wrong. You can say it's probably wrong. You would have expected a positive outcome. Yeah. So the more I weigh, the bigger my waist measurement. Taller, wider. I know it's not much, but it's quite a weak. So maybe if there is positive, kind of makes sense. Yeah. That's probably right. That's probably right. There's no reason to doubt that. So that's probably right. Similar reasonings, you'd expect a positive, I guess. Okay. Right, into the calculator we go. Let's have a go at the next question. I'll find a year reference for you. Calculators at the ready. So that was 2012. Now I'm going to look at 2007. So into the calculator, list 1 and list 2 these values, please, and interpret your value. And remember your key presses, calc reg x. We're doing a regression calculation. Before you can do a linear regression and model as a plus bx, you've got to hopefully have that linear relationship. And that's what correlation is testing, or at least what PMCC is testing. I do reckon we've got a value and then interpretation. Yeah. Negative.
Yeah, minus 0.525.
525, yeah. Yeah, 525. Yeah, minus 525, yeah. That is negative. If you're going to quantify it, you can't say strong, you can't say weak. It's slap bang in the middle, 0.5. Moderate. There is a moderate negative correlation between. They would have accepted weak, they would have accepted the word some. Moderate is the way to go, it's slap bang in the middle. Moderate negative correlation between, what was the context? Length and maximum diameters of honeydew melons. That's interesting. So the longer the melon, the smaller its maximum diameter. That's fascinating. I mean, you've seen them, haven't you? You've seen those long, skinny watermelons, yeah? The good watermelon, the good ones, the almost spherical ones, they're still kind of a rugby ball, aren't they? They're not quite a rugby ball, but you know what I mean? They're almost spherical, almost. They're the standard ones, but they do exist, the longer and skinnier ones. That's fascinating. So moderate negative correlation between length and maximum diameter of honeydew melons. Okay. Yeah. Alright, pretty standard stuff. Those 4 questions is a variety of different types of just straightforward correlation questions. we look at correlation testing. So if I do one of those, just a reminder using the CV from table 8, and then obviously next week we can do some Spearman's ranking. You'll be doing some Spearman's ranking in class anyway, and then we can make a decision whether we want to do Spearman's ranking next week. All right. To be honest, I doubt you will, but you can practice your ranking in class. And I've said that on lovely. Right, let's have a look at a correlation test. So what I want you to do is the next one I find is I want you to work out the test statistic, i.e. the PMCC. Yeah, there it is, lovely. There's your data. Do you want to zoom in on the data on the table? And instead of interpreting it, we're actually going to test it at a 1% level. So Jan 2006, work out your PMCC. Hopefully we get a strong coefficient, and hopefully it's stronger than the CV. I'm hoping we're getting negative because the actual test we're going to carry out is a negative association test. So those 4 exam questions, granted legacy exam questions, were all paper 1 questions. What makes this a paper 2 is the fact that it's a statistical inference, it's a hypothesis test. So we'll need a hypothesis, the test that is what we're working on for part A. We'll get a CV, is the test that big enough, and then make a conclusion based on that. It says negative, so it's a 1 tail. And less than. It's just what Greek symbol do we use as the parameter, the population PMCC. Then the CV comes from table 8. Comes with Wilcoxon's table 9, Spearman's rank. I need to remember it because it says at the top of the page, table 8, PMCC. Right, we get minus 0.708. Yeah?
No, that's terrible.
Alright, so check your data. Check, you get minus 0.708. Yeah?
Yeah.
I'll leave the data on the board for you to type in. So hypotheses, H0 to H1, it's always no difference, no association, no difference, no change, it still is. No correlation means a correlation coefficient of 0. The correlation coefficient is rho.
Got it.
Cool, lose code off and put to click on and work, yeah, and then use your pen in your hand and that's the bit of the actual question we'll do. So rho is kind of like a slanted P without a hand. So P kind of has like a little tail here. Yeah, whereas if you do it as one continuous character at like a 45-degree angle, then it says negative, so it's a one tail. We're only testing the left side at the 1% level for 11 values. That R value of minus 0.78 becomes our test number. Okay, that is what the sample has told us. Our sample has told us, look, the correlation coefficient of this sample is that. Now the question is, for a one tail 1% and sample size 11, is that strong enough? Okay, did you manage to get the right value? Did you manage to check everything was typed out? Okay, yeah, cool. Right, so let's have a look at table. Let's have a look at table 8. So our formula booklet. Oops, there we go. Our formula booklet, and you're looking right at the back end, because at the back end you're looking for your CV tables. Right, there isn't a dist lookup on our calculator for this. So the last 4 tables, the rest of the tables, like table 1 to table 7, the calculator does it so much more efficient. It's probability different. Yeah? No thank you, or CV different. This one's not so bad. One tail, 1%. So if it was a 2 tail, we'd be looking at the second one. But because it's a 1 tail 1%, which is equivalent to a 2 tail 2%. Yeah, 1 and 1 making 2 overall. 1 tail 1% for a sample size of 11. Sample size 11. Now we've got to be careful here. Sample size 11 produces 6851. Alright, so you're looking at it, 6851. You're about to write it down, you look back, and you see this, 6581. It's the worst CV to look up because 6851 and 6581 are right next to each other. Many students have lost that mark in a mock, in a real exam, or whatever, because sample size 11, sample size 12, 6851, 6581 are right next to each other. And if you suffer from dyscalculia or dyslexia, that will mess with your head. And it upsets me. Alright, so we're being very careful. You can use rulers to look carefully. You can use two rulers or a pencil and a ruler, whatever. 1 tail, 1%. Scrolling down, it is 11, 685, 6851. Okay? Sneaky. Sneaky. Let's have a look at what we get. CV, I've forgotten it already. 8, 6, 8, 5, yeah? So they're going to look back and find the final. Now, to get the mark in the exam, I've got to remember something here, because the table itself gives me that value. I reckon that value got the mark, not for this test. Why not? Why is my CV not quite right? It's the correct number, it's the correct value.
Because there's a 0.
There's a what, sorry? No, the data's fine, the data's fine, the test stat's fine, the CV number is fine, but to get the mark for the CV, I need something additional.
Plus one.
Not quite plus minus, because that would be a two-tail test. Just minus, because it's a negative one-tail test. So because we're testing the negative end, we need that minus. Very important to get that full mark. You could use a number line on a scale of -1 to +1, and you can say how -0.708 is outside the threshold range, okay? And that's a nice little visualization, if that's what you've been shown, then by all means. However, what I like to do as a general rule of thumb for every hypothesis test, except for p-values and Wilcoxon. Except for p-values and Wilcoxon. All right, thank you for reminding me. Is that if your test stat is bigger, your sample has told you that measure is further away than 0 than you see it. And that's what we've got here. Yes, minus, but 0.7. 0.7 is bigger than the threshold of 0.685, isn't it? That is significant. That is evidence of a negative correlation. So, how do I ignore the minus then, Philip? An acceptable mathematical symbol is to use two vertical lines either side of your number. Alright, you appreciate that the test stat is negative 0.708, and you say, look, I'm just going to ignore that minus. That's what the absolute value is. Modulus signs, that's what they refer to as modulus signs. The modulus of negative is just plus. 0.7 is bigger than 0.6851. Both our test stat and CV were negative, so I needed to mod both of those. 0.7 is bigger than 0.68, so we reject the null hypothesis. We're going to reject no correlation because there is evidence of negative correlation. Significant is the full word that you write in the exam. Evidence is the full word that you write in the exam. I think it was like average temperature, average daily temperature in the first 6 months of life for these babies, yeah. And what was why? Why was the age in weeks of the crop? Or learn to crawl, however it's worded. Okay. So yeah, straightforward correlation would have been enough, but I think at past, I think we were like, do you know what, we've done that, we've absolutely smashed that in the park. How would we extend that? We'd extend that to MCC, so if I give you a bit of a heads up, one more additional examples, then when it's shown again, even better. Yeah, because we'll do that this week. If not this week, next week. Yeah. So we'll be chipping away that list. If you do print off that list, just want to check our answers. Yeah, test stat. Test stat is bigger. Now here it says test stat less than, because it's the other side, and I think that's quite confusing. Positive with positive, so it's not positive with positive. Well, not positive with negative. You can do positive for the comparison, but you needed to have the minus for CV. There's a typo error. What I wanted was this list. Alright, can you see how that one there where I tagged you? Alright, there's the PDF. You can print that off. You can download and then print off. Yeah. And like, if you print it off and start ticking off for lessons, that's fine, but make sure you tick it off in your own revision as well. Yeah, your own revision needs to take place to supplement what we're putting on for you. These things are always afternoon fantastic. Take that off, but maybe do some yourself as well. Alright? Plenty of stuff to be getting on with. Tick off a lesson, tick off a tutorial, tick off your own revision. Yeah. And if you're getting three ticks for all of these, you're in a better position than 0 or 1. Okay. Alright, thank you very much for your attendance. Hope to see you again next week.
Thank you.
Yeah, and positive vibes for February.